So let's say I have geometry here. Let's say I just have a curve in Rhino, right? What I can do is in Grasshopper is that I can bring it in. So if I type in curve, this is called a container node. And what these do are they link geometry in Rhino into Grasshopper. Yeah. So Grasshopper here, you can see the interface. So everything's in nodes. So you have a box. Usually you have an input and an output. Some nodes don't have an input. Some nodes don't have an output because they do something else. And basically information goes through the input. So information comes in from the left and flows to the right. Yeah. So here, if I right click on this, set one curve, you can see now this is highlighted in green. And what this means is if the information I have inside this node here is this curve. If I click away from the nodes, you can see it's black. It's just Rhino geometry now, right? So I can hide that here. And you can see it's in red. Red means it's referenced in Grasshopper. Green means I've selected it. Yeah. And you can see I can't select anything in Rhino. And that's because I've hidden the geometry, right? So I can unhide the geometry. And if I move this here, you can see whatever I move in Rhino automatically gets updated here, right? So this is the piece of data I have at this moment. It's within this curve container. Yeah. So what I can do is I can draw another curve, right? I can add more data to this. So I can select both, right click, set multiple curves. And now you can see when I click on it, these two turn green. And that means the data inside here contains these two bits here. And when I select this, I'm not selecting the actual Grasshopper geometry. I'm selecting the Rhino geometry. Yeah. So I hope that differentiation makes sense. So what I can do here, I can hide the Rhino geometry, so I can't really select it, you see. But the data is still in here. So in Grasshopper, you can't select any geometry directly. All you can do is view it. So as I'm doing here, so I can view the geometry that's referenced in, but I can't select it. And what I can do again is manipulate it. So by manipulation, I mean anything, right? So you can move, scale, rotate, make it wobbly, make it straight, wherever you want. And you can see here, these are all the different tools, right? So the basic tabs here, I got primitive, so PRM, I think that stands for primitive. Oh, params, sorry. I have math, so this is for addition and subtraction. So let's say I want to scale a line, right? So I type in the scale. So this is a different kind of node. So this node contains a function within it. And with this function, I give it some sort of data. It does something here, and then it gives me output of the data. Yeah. So this is completely independent, contains data of two lines. And this is a function that I can use to do something to that data here. Yeah. So if I hover over here, it's asking for a geometry. Yeah. So you can see when I hover over geometry on the top left, there's a spiral, and that indicates to me that that spiral means a curve. Yeah. So in Rhino, everything that's linear is a curve. Even a straight line is a curve. There's a reason why they call it a curve. But just for now, at this stage, just think of everything that's a line or represented as a line of some sort as a curve, right? So I can bring this in, and you can see what I've got here, right? So if I select on this node, you can see this is highlighted in green. So this is the data in this node. And now if I select on this node, you can see the geometry highlighted is over here. Now, you might be asking yourself, why the hell has it done that, right? This is a case of it not doing what I want it to do, but doing it what I'm telling it to do. So with coding, that's what happens, unfortunately. You want to do things, but sometimes it does what you're telling it to do rather than what you want it to do. So all we have to do here is look at the information that we're giving it, right? So these are the inputs for the scale function. And basically the way I can control the function and the output is through here, through the inputs that I give it. So if I hover over any input, it can tell me what the data of that input is expected. Yeah, and it gives me a hint as well. And if you also see in the bottom, there's squiggly brackets, and there's 3 numbers in them. Yeah, and what that tells me is that this node and this input has a default value already in it. So if I don't give it anything, you see the function has completely completed its operation, right? Despite me not telling it where the center of scale is, and that's because it has already default value. So the center here is 0, 0, 0, and you can see on the top left there's I think that's an octagon, right? Yeah, so an octagon with an X in the middle, and what that means is that that's a point geometry. Yeah, so what I'm doing here is taking these 2 curves, I'm scaling them in this center point, 0, 0, 0. Yeah, so that's a point in 3 dimension, and 0, 0, 0 is somewhere here. What I can do is something called construct points. So construct point here. I'm just gonna turn this off because I don't need this at this moment. And if I zoom out, oh yeah, so you can see this is the, forget about this, let me do that as well. So if I zoom in here, I can zoom in a bit more in just a second. So 0, 0, 0, enter, zoom, extent. Okay, oh yeah, finally. So if I zoom in right here, you can see that this point, again, a point is made out of 3 pieces of data, right? So X, Y, and Z. That's how you represent a 3-dimensional point. You can see here, so I have a number. So right at the bottom of that pop-up, you can see a 0, and that's the default. You can see another 0, and you can see another 0. So you can see this point in my 3-dimensional Rhino space is drawn here at the 0, 0, 0. So this is my 0, 0, 0 point in 3-dimensional space. Yeah. And again, with anything really, I can change this value, right? So if you here, so this is a function. Whenever I give it a new input, it'll run again. So at the moment it's running on 0x, 5y, because I've given that slider here, a number 5 in the y direction, and again a 0 on the z. So if I move this, you can see my point moves around, right? And I can use this for this as well. So it starts moving diagonally in the x and y, or I can just give it, well, 200 is a bit too much, just give it 10. And I can give it a completely different number here. So I can move it this way a little bit, and then move it inwards, whatever. Yeah. So hopefully that's making sense with the whole workflow and everything based on data and functions applied to data. Yeah. And data here means, again, geometry, or it can be even, numbers, and it can be anything. So let me delete that now and figure out what's going on. I have to zoom out. Okay. Right. So you can see here, going back to this, I have a curve. I have a center over here. Yeah. So my center is in the 0, 0, 0. Can anyone tell me why has this function generated the geometry halfway through over here in the middle? And if I hover over here, maybe there's a bit of a clue. So if you know the answer to this, unmute and speak, yeah? I know a few of you here know it already, so.
Is it because the factor is automatically set to 0.5? No.
Yes, that's correct, yeah. So hopefully that makes sense, right? So if I have a line, I'm drawing a line from point 0, 0, 0, so I'm just drawing it on Rhino here, enter. And this is my line, right? So I'll just draw it up to here, enter. So this is my line, right? So let's do the same workflow but in Rhino and not in Grasshopper, so you can understand what the difference here is. So if I take this geometry, I scale, so this function called scale, but there's also, you know, in any 3D modeling software, there's also another function, right? So I can go scale, enter. It's asking me for a base point. Where do I want to scale it from? Yeah. So if I scale it from here, the point 0, 0, yeah. And now it's asking me for a scale factor. So how much do you want to scale it? So if I want to scale something by 0.5, it means I want to make it half the size. Yeah. If I want to scale something by 2, I want to make it double the size. Yeah. So simple multiplication. 1 times 1 is 1. 1 times half is half. Yeah. Exact same principle. So with here, we know the default value is 0.5. Now, I have a base point. I have my geometry. If I give it a factor of 0.5, enter, you see my line is shrunk up to this distance. Yeah. So what I can do here really is if I take these two curves, and what I can do maybe is, how am I going to get the center point for the two curves? So maybe I can do something like this. I'll just make it 1, so it's easier to follow. So I'll delete this. I'll hide this. I'll hide this. So now I have only one curve, right? So now what I can do is I can find another command called point on curve, for example. So point on curve. What point on curve does is takes a curve, and then with a slider I can control where I want that point on the curve. Yeah. So 1 will be at the end, 0 will be at the beginning, 0.5 will be halfway, right? So if I just change it, there we go. So I know that point is halfway through my curve. And this gives me a point, right? Because every time I click on it, I can see that I have a green point that comes up. So if I change this to the center over here, the whole scaling is different because I'm changing the center from 0, 0, 0 in the 3D space to the midpoint of a curve. Yeah. So if I bring this in, you can see with my scale command, I've scaled all this from this point and made it smaller. Yeah. And you've seen how we've replicated the same operation in Rhino over here. So yeah, so you can see, look, by changing the location of that scaling point, I'm changing the whole position of the new geometry, right? So if I'm scaling it from the beginning of the line, I'm getting a replica of that curve at the beginning of the line. And if I'm scaling at the end, I'm getting the same, but at the end of the line. Yeah. And I can also change the factor over here. So the factor, you can see on the bottom, it says 0.5. I can make it 2. And now it's 2. I can make it bigger or smaller, and I can change it. Yeah. Okay, so that's so now you know what a container curve is. Now you know what a function nodes and what the functions they can operate. You know what kind of inputs. You know how to hover over different inputs and read what's required and what the default value is. And now you know that everything in Grasshopper flows from right to left. So I can't take this. Yeah. So this is an output as a result of this input, right? I can't take this output and give it back to the input. You can see the whole thing just crashes, right? Because how are you going to scale a curve and then get an output and then scale it again and get an output? This is not how Grasshopper works. Yeah, everything is linear. So you start from the left. So if I Control Z, and you go to the right. Yeah, and then here I can do whatever I want. So let's say I want to rotate it. So I can, again, I have the geometry, right? So this is my output, this line we just scaled. Again, in Grasshopper, something very important to know is everything is duplicated, right? So here, this is a completely different curve to this one. Yeah. So if I want to go back, save this curve, I can right click, bake. So if I right click, bake here, okay. So baking in Grasshopper is is translating Grasshopper geometry back into Rhino. So once you bake something, you can go back and click it. Yeah. So you can see I can click this curve now. This is a new geometry that I just created by baking it. And here again, because once I select, I can see this is turned green. If I right click, bake, see, wait, before that, I just want to show you I can't select anything. So this is completely in Grasshopper land. There's no Rhino geometry at all, right? Right click, bake, okay. And now I'm taking that representation in Grasshopper and I'm making it into a geometry that I can actually do whatever I want with, export to Illustrator, make into building, etc. Yeah. And if I delete that, of course, it doesn't affect anything here because this is completely different. Yeah. The only thing connecting me to the Rhino is the original curve. Yeah. All this is just duplicated. Yeah. So what I can do now is I can take this geometry again. I can pop it into the rotate. I can take the same plane. So there's different kinds of constructs worth learning. Yeah. So one of them is a plane. And I think these are worth, taking notes. So what is a plane? What is a vector? What is a mesh geometry? What is a surface or NURBS geometry? Yeah. These are the main things, and the more advanced concepts are things like lists and data trees, and these are fundamental to working in Grasshopper. If you don't get your head around these concepts, there's no way of being good at Grasshopper. So it's worth really exploring those. And there's a good book that covers a lot of these kind of concepts related to geometry, computer geometry, and the book is called Elements of Parametric Design. I think the author is called Woodley, if I'm not mistaken. I can get it up just to. Woodbury, yeah. So this book over here. Once you understand what all these kind of things, like plane might be something completely kind of strange to you at the moment, right? But it's a very, very basic principle. Plane is just a kind of an imaginary 2D surface where you can reference things in. I know it sounds abstract, but something very useful. And you can represent a plane by a point. So if I just give it a point here, you can see now I have an original curve that I referenced in from Rhino. I have the point that I'm controlling. So the point here is at the end of the curve. I've scaled the curve from the end of the curve by a factor of 3. Yeah. And then I've taken that geometry and I'm rotating it. I'm rotating it in the plane. So the plane is also a location where rotation happens. It's also related to vectors. All vectors have planes. So plane. And the strange thing is that it rotated something without us really telling it by how much we want to rotate it, right? So we're given a location where to rotate by and the geometry. And the only thing is missing is the angle. So if we hover over, we can see 0.5 times pi. So angles can be represented in 2 ways, by radians or degrees. We are more familiar with degrees. Triangle having, if you have a perpendicular line, it's 90 degrees, that kind of thing. But you can also demonstrate it using radians. So in radians, 0.5 times pi is 90 degrees. Yeah. This is taking a lot more time than I'm expecting, because if I don't cover this, none of what we're going to do is going to make sense. So I hope this is making sense. Just to show you very quick, I'll show you how to translate between degrees and radians. Yeah. So no, the other one, radians. Okay, so here, so this node takes the degrees, so 180 degrees, and translates it into a radian. Yeah, you can see it's very simple operation, something very familiar in trigonometry if you've done that in school. It's just a different unit of measuring a certain value, and it's a straightforward thing. So you can see here, this node has nothing to do with any geometry at all. It's only taking a number, and it's giving us another number, and this number is presented in pi. Yeah. So not all nodes have to be related to geometry. You can just take in random data and manipulate them like this. Yeah. And I can take this in this radian, plug it in here, and you can see I've given it 180 degrees, and it's rotated the whole thing by 180 degrees. And because everything is based on these two, I can, if I just move anything in any, move these sliders, I can do some crazy stuff, right? So yeah, everything's interrelated, yeah? So everything just trickles from the left to the right.